Hello everybody, welcome to this Onshape tutorial. My name is Ake. On this first episode, we're going to be focusing on using the extruding and the sketching functions within Onshape to create a very simple part. The goal of this series is to really enable you to go away, look within your environment, identify your unique user needs, and design and craft parts that meet those needs. That's why each episode will be centered around the creation of a unique functional part. And at the end of this video, we will have created our very first part together. Thank you for joining me, and let's get into it. First things first, before we can do any modeling, we need to create an account. So on Onshape's main page, you click sign up now. Oh, that's a no. How did you hear about us online? After this series of questions, you click complete sign up. All right, after validating our account, we now have to go through a few setup methods for the modeling. First things, we have to choose a unit for length. And because I live in Europe, where we use the sensible measuring units, shout out to my American friends. We love you. We're praying for you. I'm going to change this to millimeters, and I'm going to change linear acceleration to meters per second squared. We can leave the angle the same, but there's nothing else we need to do here. Next, this part here is quite important. I would recommend we change that to SolidWorks because what that does, as you can see here, it concentrates your experience and focuses that on your middle mouse button. And I would say SolidWorks typically is a typical input method for CAD systems generally, in my experience. So let's change that to SolidWorks from Onshape default. Next, you give it your name, and now it's going to run a quick browser check just to make sure your browser's kosher. And we're ready to go. And if you miss out on anything and you click the wrong buttons or you selected the wrong options during your setup, you can go here, click by your name, click my account and preferences, and you can do all of the same settings again. So here you can choose between light mode and dark mode if you want to. Um, if you want to change your units back to imperial, that can be done here. And you can also change your mouse settings here if you are not comfortable with using SolidWorks. To start this series, we're going to start with creating a wall bracket for this Meross Presence Sensor here. To get into a bit of functionality that I require from this, I want this to mount to a wall bracket using this part of the design here. So that's going to slide up the wall bracket with the wall bracket itself being screwed to the wall. Um, I also want a level of self-retention within the wall bracket itself for the mirror so it just doesn't slide down regardless of whatever orientation I'm mounted in. I've gone ahead and done all of the measurements for this. So just to help with the flow of the video, and then, we can start with modeling this and introducing the concept of actually creating your own parts in Onshape. All right, now that we've completed the setup for Onshape, we can start creating parts. So we'll start by, creating a new document by clicking the create button. We'll name this Meross bracket. I can't type. Bracket. We create public document. So this is the interface that you primarily be dealing with. I'm just going to show you a few things and point a few things to your direction. On this part here, that's where your part history lives. So that's the history of the model that you created, all of the features that you've assigned lives in this window here. At the top here is the tools that you'll be using to create your model. There's a lot here. So today to create this part, we're only going to focus on sketching and extruding. Those two here, you can see the shortcuts assigned to them. This big surface here is where you will be doing the modeling. It's the model window for this. And on the surface, you can see three planes here. So you can see the front plane, the top plane, and the right plane. So the top plane is kind of on the floor. The front plane is the wall in front of you here. And the right plane is kind of like the side wall. I will advise as beginners, you draw on the front plane. And also, but more importantly, when you're doing this, you want to make sure your z-axis over here, where my mouse is here, is pointing up so that as you begin to model, up is up and kind of sideways is sideways. And the black dot there is the origin, is your point 0, 0, 0, where you should model to, and it allows for easy constraining of your sketches. So the first thing I'm going to do is select sketch, select the front plane, and I'm going to use the shortcut N. And what that does is it rotates that into plane view. Because I'm not using that two planes, I'm only using the front, I'm going to go ahead and hide the top plane and the right plane so the model is not as cluttered. So the most important rule here is that we want to get rid of the blue lines. And what does the blue line mean? The blue line or the blue shapes mean your sketches are unconstrained. So if I put a circle there, right here, and let's put a center square anywhere. So these lines are blue because they're not constrained. They're not constrained in space. They're not defined. The computer is guessing where they are. So if I go escape and I try to move this, I can move this around. You can see that I can move that around. I can make this bigger because it's not defined. This same for this. I can move that around. I can make that bigger. I can bring that in. I can bring that back out. And that's bad. And that's bad because as your model starts growing, as they become more layered, they start to break because the underlying sketches are not constrained. So to constrain this, I'm just going to go ahead and delete this here. To constrain this, you need to do two things. You need to give it a location and you need to give it size. So for the circle, for example, the easiest way to give it a location is just to draw on the origin. I messed that up. Let's try again. On the origin. So you go on, you select the origin, and you put in your circle. Now you've constrained that to a location. So if I click escape and I try to move that, I can make it bigger because I haven't given it size, but I can't move it away from where it is because it's constrained. And the other element is giving it size. You go dimension, you go and you put your dimension and it's black. And that's constrained. And it's that easy. You give it size and you give it a location. So same for a square. So we could do select the center square. It's easier because you can constrain it. So you select the origin, you put that there, right? So now the center of that is constrained, and all you have to do is just give the sides a dimension, that there, and that there, and everything's constrained. So that's the biggest thing you have to achieve with sketching. So now we're going to go ahead and sketch our bracket here. I'm just going to remove all of this and create a sketch for our bracket. So that's deleted. So what we'll do first is we'll create a rectangle for this. So about that size. So we want to give this rectangle, as I mentioned, we've given it a location by constraining around the origin. We want to give it size. So the length is 77.9 and the breadth is a size there, 43.4. If you zoom in by scrolling the middle wheel, uh, bring that down slightly so it doesn't get far from the screen. So now I want to draw the holes for the mounting bracket for the mounting screws. So I'm just going to going to go with a center circle there. Um, select, select. So we're going to dimension that 5.72 and also 5.72. Now we have to place the circle in the location. So we dimension relative to the edge of the rectangle because we can also constrain our curves that way, not only in relative to the origin, but also to a feature that's already constrained. So I will constrain the height of that circle there. That will be 13.95. And I'll also constrain the center position of the circle. That will be 21.55, or roughly halfway here. I will do the same for the top circle there. So I will dimension the two circles relative to each other here because again, we can do that. So I will select the two dots and we know center to center position is 50. And then the last thing I need to do to place that circle, because if I go escape, you can see here that I can still move that circle around. I can't move it up and down, right? But I can still move it side to side there. So we need to sort that out. So now we need to dimension that from the side. So We'll do that here from the side. That will also be 21.55. So now that sketch is fully defined. I'd like to show you a different way of actually achieving this without having to put this many dimensions, and those are called sketch constraints. So again, I'm going to go ahead, I'm going to click escape, and I'm going to delete all of these dimensions here. So I will start this again. So delete all of that, delete. So again, we'll go with a rectangle there. We still need the sides and shape of this. So for the 3.4, and then we need to dimension the length of this rectangle. This will be 77.9. So that still needs to be placed. But rather than having to use a lot of dimensions, we're going to use something called sketch constraints, and they're located on this side after the dimensions. So all of this here are sketch constraints, and they allow us to add different constraints to different functions, to different elements of our sketches. So I'm going to go now and place the two circles in there. I'm just going to place them randomly at the moment just to illustrate the point. So the first thing we're going to do, we're still going to have to dimension this circle here. So we're going to say, again, as before, 5.72. But now that we've placed this circle, we can do something. We can escape, select the circumference of the circle, and select that circle, and we'll use an equal constraint. So we're basically telling them that those two circles have equal radiuses, so equal, and now you can see the dimension, the size of that circle is changed. We can also use what I call a vertical constraint to, because this is centered around this shape here and is in line with the origin. We can use that constraint there, vertical or V. So you select the center point of the circle and the origin, and then that aligns that to the center point of the origin. And the last thing we need to do to give this a location, because as you can see, I can move this up and down, but I can't move this side to side because it's now constrained to the origin, right? So we now need to constrain the vertical positioning of that. So the last thing for me to do is use a dimension as we did before, go to the center, and that number is 13.95. So now that circle is constrained. We can further use the vertical dimension. So to also lock this top circle in, we can either do that to the origin or, as I mentioned, to another constraint point. So I'll go vertical again, select that, and we'll select the circle there, and then that's moved that to the center. And the only thing that we need to create is the vertical positioning of this, because again, we can move it up, we can still move it up and down, but we can't move it side to side. So what we need to do is just go there again and select the two circles, and we know that dimension is 50. And again, we've been able to achieve the same thing, but with relatively minimal required dimension. So that's how you can use sketch constraints to also constrain your curve. And there's a lot more that you can use here, and I will get up to it as we move on in the course. Now that we've created a sketch and it's fully defined, we can press this green tick here and go out of the sketch window. And we'll proceed to extruding. Before we extrude, I want to give you guys a little pro tip, which is to just name your sketches. And I say that because I imagine you guys will emerge from this course, right? Being able to actually do various level of complex modeling. And as you're doing that, right, naming your sketches allows you to actually find your range, and it makes kind of the old process of modifying your models once it's created easier. So to do that, it's just as easy as right clicking and renaming. We're going to call that base sketch, press enter, and now that's renamed. And once that's done, we can go ahead to actually extruding and actually start creating the shape of this. So to extrude, we'll press that button there, the very first one after sketch, and we select the inside of a sketch. Onshape is defaulting to the closed area into the sketch, and as you can see here, we have three. So we're going to select that middle part there for the first bracket, for the first bracket mounting hole, and select the other one. So you've created your first shape. There's so many things you can do within this option here, but for now, we'll focus on giving it a thickness, which we know is 7.5 millimeters here. So now that's done. We've now created the base shape of this, and now we click the green tick, and then we're done. So now we need to create the sliding portion of it because I remember I mentioned that I want the Meross sensor, this part here, to slide in and out of that, and as I also mentioned, to somewhat self-retain it, so we don't want it loose, so we need to also control that there. So we put that to the side. So to do that, we're going to sketch on the side of this. So to do that, again, we click sketch. In this case, we're not sketching on a plane, we're sketching on the face of the shape that we created. So we select that face there. Again, as I mentioned, shortcut N, that rotates that into plane view. And now we have a surface to create our sketch. So to do that, we need to do one thing first. So we're going to create a center line at the bottom. Again, center line because it's just easier for us to constrain it, right? So I will just do that there. So now we have an horizontal line there. Again, to start giving this a location and size, I will use the vertical function there. So I will click vertical, select the center point, select the origin, and now the center to the origin. So if I escape quickly, I can move this up and down, but I can't move this side to side. I can still make it bigger, right? Make it longer because I haven't given it a size there. So yeah, we'll proceed to do that. So we'll click dimension, select the two origins, and we know that is 2.5. So that gives us an overall wall thickness of 2.5. Also, we want to give this a length because again, we've given it a location, but we haven't given it size. So I can still kind of move it all the way around there, right? So we need to dimension the two endpoints there. And that number is 38.6. 38.6, which corresponds to the overall width of that sliding part there of our mirrors. So that's where it's going to slide in. Then we want to actually create the slots where we slide in into the mirrors there. So we're going to go, this time we're just going to select a normal line and draw line upwards. We know the thickness of this is probably about 2.7 mil because again we want it to self-retain, so we don't want it to be too loose. So for now we will match that. So that will be 2.7 millimeters. So we want, because also we want this to overhang, isn't it? So we want it to not fall back out. So we will need an overhang of that. We want an overhang of 2 millimeters there. So I will do another line there, escape, and give that a dimension of 2 millimeters. Now that we've done that, then we can go ahead and start closing this shape here. So what we want to do is just move that up there. And you notice that line there is black because it's stopping at the top of the surface there, which is already constrained. So we don't actually need to do anything else on top of that there. So we've done one side of our slide. But because this is symmetrical, right, across the center, we can do a little trick here. We can use another feature of the sketch curve, of the sketching function, to mirror that to the other side, to this side of the model. To do that, we need to do one thing first. We're going to put a line there, but this line here will be different. This will be a construction line. So it's a reference line that doesn't actually have an effect on the overall sketch. And to do that, the easiest way to do that is just click on the line and use the shortcut Q. So now that's made that line dashed, and now we can mirror around that line. So to mirror, we use that feature there, the mirror feature. We click on it. So it's asking us to select a mirror line, which is a center line there, and then entities to be mirrored, which is the lines to be mirrored. So we'll select that line, and that line. And because again, we're mirroring a line that's already constrained, right? The line that we create on the other side is already also automatically constrained. So the next thing we need to do is close that curve there. So we select a line there and close those 2 points. And now that curve is closed and fully defined and for us to do our slides with. So as I mentioned, again, back again, we click the green tick and we somewhat move that with the center line so we can see our shape there. So the shape is in there. It's not quite clear, but By scrolling out, you can see the overall shape. So that's the shape of our slide. And what we want to do is, again, we want to extrude that inwards, right? So we select that shape. So this time we actually want to go into the model. So we click that part there. So now that's going in. It's red right now because we're putting a part inside of a part essentially. And Onshape doesn't allow that. It will result in no geometry being created. So what we need to do first, but we still need to give this a length. So we want an overall wall thickness of 2.5 millimeters there. So as you remember, our sketch is 77.9 millimeters long. So that needs to go to around about, let's just say 75 roughly, 75 millimeters. Because we don't want this to go all through, we want this to stop somewhere. So now that's done, it's still red. So what we want to do is, because that's a slide, that's an open part inside the model, we want to remove this from the block that we already created. So instead of saying add there, we'll click remove. So now we've created the slot. Now that that's done, we click the green tick. And now that we've created the sliding part of our part, we need to create the mounting nose for our brackets, which allows us to actually screw this to a wooden piece in the wall. Now that we've created the sliding part of our part, we need to create the mounting nose for our brackets, which allows us to actually screw this to a wooden piece in the wall. I intend to use wood screws with this. So before I actually put in the mounting nose, I need to kind of talk more about the functionality. Remember I said this is kind of sliding up on this phase here, right? So you don't actually want anything coming out of that phase so that to get in the way of this actually sliding up and down. So the head of the screw needs to be either level with this plane or below the plane. That's one functionality. Also, you also want the screw themselves, the screw trace, to actually clear the holes because you don't want to be screwed into the plastic. You want to screw it into the wall. So you need to make the actual hole also big enough to actually be able to pass the screw it, so you can use your impact drivers or whatever to screw that into the wall. So for the sake of this, if we're using a, let's say number 4 wool screw, for example, so we need the head of the hole itself to actually be bigger than 8 mil here, and the thread diameter to be bigger than 4 mil there, right? So that it can clear, it's called a clearance hole, it can clear the hole that we're making. So we go ahead and do that in Onshape. Again, everything starts with a sketch. So we sketch, we select that face there because we want our sketch to be on that face. Again, and to bring it into plain view. So I'm going to introduce another way to create a sketch here, which is to project a separate sketch onto the surface that you've created. Since we already have a sketch for the hole here, right, we can simply use the project feature or in Onshape sketches to actually project that sketch onto that face there, because if we try to put a hole on that, we can't do it because it's not on that plane or on that surface. So we use the project function here, or letter U, we'll select the two sketches there, and we've put a sketch on that face there compared to the old one that was on this place here. So you can kind of see what we've achieved there. And because this sketch is defined, this is also already defined. So we click the green tick to come out of that. And we're going to use the all function to create this. We can use for this. So we click the all button there, that one. So there's several options here. For the sake of what we're doing, we're going to focus on countersink, i.e. that shape there. So it's countersunk. So first we'll select the all size there, but we know that if we're using a number 4 here, we want it to be bigger than the size of the thread there. So that needs to be greater than 4. So the all size here will be, let's just say 4.5 or even 5 mil, right? This might vary depending on your print settings. And the angle is 90 degrees as we know from there, and to get this to actually countersink to be below or level to the surface, it needs to be more than the overall diameter of the head itself. And we know from here is 8. So we'll make that 10. So now that that's done, we've created the parameters for that hole, and then to place the hole, we select, sometimes this is not automatically set, but here it's selected, we select the center point of that hole, which is the center point of the circle we created. So we select that, and now the hole is automatically created for those two locations there. We click the green tick, and we are done. So congratulations, you've now created your first part in Onshape if you're following this, and it's ready to be mounted to the wall. Before we do that, we need to kind of make this prettier, right? So we'll add rads to surfaces there, so radiuses, and it also allows it to, it looks a little bit better when it's printed, which I would imagine will be your aim for this anyway. So we'll just select all of those phases there. Actually, an easier way to do is just select the whole thing, right? And it selects all of the phases and it just adds all of the rads. And if you want to make that bigger, let's just say we want to make that 0.3, do that. Click the green tick, and now you've added radiuses onto all of your holes, and this is ready to be made. In the next lesson, we're going to try and build on some of the elements that we've been through today to create this kind of more complex Raspberry Pi cover. We'll be going from a model with few sketches, to a more complex and I'll say more kind of more professional level type modeling task, but still leaning on the same concepts that we've spoke about today, extruding and sketching. So thank you guys for watching. I'll see you on the next video.